Okay, all. Yes, well, let's start. Actually, to be honest, this is my first talk in a conference, so yeah, I'm kind of nervous, you can understand. Well, thank you so much. So, because of that, for distracting a bit of nervousness clouds about me right now, just need to talk about what is ephemeral namespace, or how did I appear here? What's the story? Well, 2 months ago, I started working on implementing a CI/CD pipeline at LaunchPad Central, and then, well, thinking and reading a lot about namespaces. So the idea came about, well, what if we just run identical environments with a namespaces before testing our up-to-date code? So what if we make use of these? And then another thing happened supporting the idea. We had a DevOps candidate out there, and then we were talking with him, and then he mentioned about they're using separate namespaces for each of their environments. And I'm realizing that this is a common approach around, and I also saw that within the chat-up session today. And well, I will try to break that idea, and I will have a focus on namespaces today. So let's start. What are the highlights? So we are going to mention about fundamentals of namespaces today, and I will try to break the idea of having separate clusters for each of your environments. And we are going to talk what is ephemeral namespace. Well, this sounds cool, but we're going to see if it is really cool or not. And we will try to run every single piece as Kubernetes components. And yes, we are going to talk about some of the Kubernetes early stage features that didn't work well as I expected. So these are the highlights for today. So what are namespaces? Well, I just get this quote from the documentation. It says, a namespace is a mechanism to partition resources created by users into a logically named group. Which means, or I'm going to focus two parts here, partitioning resources and logical named groups. I think you're mostly familiar with this logical named groups because if you just have an up and running Kubernetes environment, you already saw that kube system out there. And well, and also we'll focus how we are going to partition resources and how we are going to isolate stuff. So for making use of namespaces rather than clusters, we need to make some isolation on different levels. So why we need clusters? Because, well, we are providing network level isolation out there. And also when we have separate clusters, we are just managing some access policies, so our developers are not able to access to our system. And another thing is resource control. So what I mean is no one is just excessively using any CPU or memory out there. So yeah, let's get into details of network level isolation. So are you guys familiar with how Kubernetes is making use of namespaces? Yeah. Actually, for instance, suppose that you have two different environments, and then they're called QA and staging, and you have created two different namespaces for each of these environments. So, and then also suppose that you have defined the domain name as KubeCon local. So whenever you try to create staging environment, it's creating a domain name as stage.svc.kubecon.local, and also it is doing this for QA as well. So at this point of time, we are started creating our services as well. So we are going to have a to-do service today. This is the simplest thing that I will be able to do with this limited amount of time. So we are going to create that, and then whenever we create that, the namespace or the given name, domain name is to-do.stage.svc, and it's going on. So it's like service name, namespace name, and the rest goes on. And what this thing provides us is, okay, we have identical environments here. The only difference here is we are running some different versions within QA and staging. So whenever I try to make a request from Nginx to do service, it's more than enough to just make a request to do endpoint. So I'm not given a full path or anything else. So domain name resolution is handling this part on Kubernetes. So which is making really easy to configure your services, because you don't have to give any specific endpoint definition for each of your environments. So it's just working like a charm mostly. And what else I can say? So let's get into access policies. Yes, you don't want all your developers to have access on your production service. So you need some access policies to define on Kubernetes if you want to make a total replacement between namespaces and clusters. So yes, admin is obvious. So whenever you define an admin here, they are able to access to everything out there. And these are some system-related users. I think they are created by default. I'm not really sure about that part. And here, suppose that we are going to create two users called Bob and Alice. Bob is going to have just read-only access on production, because we still want our developers to see what's going on here. Most of the time they don't care, but yeah, we want that control over that. And we want to give more power to Alice, because we want her to create whatever she wants. So it is possible to do this kind of access policy definitions on Kubernetes. So which I feel like, okay, this will be a good reason to just move away from the clusters. The only problem is, for now, it is kind of tedious to define these files, because it's mostly working like whitelisting. And I think this doesn't support wildcards as well, but again, Kubernetes guys already thought about that, and this is a beta feature out there. Access-based, admission-based access control. It is called something like that, and with this, you are able to make much more granular access policy definitions. Didn't give it a try yet, but it looks cool. So the last thing is how we are going to make resource control. So how can we trust our developers? Actually, I'm just pushing developers hard, but to be honest, I'm not a DevOps guy. I'm a software engineer, so I know what I'm capable of. So I know how to just shit out there. And so we don't want them to excessively use our resources. How are we going to handle this? Because normally, when we separate our clusters, it's easy to do that, because only our production services are going to run within the production cluster, so there will be no conflict between your staging or sandbox with this. But again, Kubernetes guys did this, resource quota. They have a definition like this, so you're able to give your namespace like, well, this namespace will be able to use just 1 gig of RAM, and then 20 cores of CPU is too much anyway. And then they will be able to create this amount of pods, services, replication controllers. You're able to make these kind of definitions. So suppose that you have a cluster with 32 gigs of RAM and 16 cores. And you're going to, I say here, Team A and Team B, but I think it's going to make much more sense that your production environment will be able to use 20 gigs of RAM out there and then 10 cores. And your QA environment will be able to use 10 gigs of RAM and 4 cores. And when you check the numbers, you're going to see that we are still leaving 2 gigs of RAM and 2 cores out there. So you can use them later on with another namespace or whatever you're going to need. And yes, I hope that you're kind of getting into the idea of using namespaces instead of clusters. And if I was able to convince you about that, just let's talk about how we can partition our environments, or how we can partition our namespace. Yes, this is the basic approach out there: QA, stage, and production. What else we can do? We can just make system or team-based partitioning. Kube system is already there. You can just create a DevOps thing there as well, or maybe you just need some environment to run only your bots, and then you can even create that too. And also you can do project-based partitioning out there. It could be example.com or betterexample.com. I'm very good at giving things new names. So when we check the documentations, well, it is kind of limited because every time it's only give an example of okay, you can just separate your environments, and they're always saying that QA stage production, and even they are not mentioning about kube system. I don't know why, but well, it's okay. But as I mentioned at the beginning of the talk, while implementing our CI/CD pipeline, I started thinking about how does it look like. First, just the conventional way, at least this was the way how we were handling in our previous company. So how do things work? Well, first we were provisioning separate machines for each build out there. So with each version we were having new EC2 instances. And then we were running our test on isolated clusters. And then, well, checking if these tests are successful. Then if they are, we were tearing down the clusters. If not, we were keeping the host. Yes, it's both expensive and also time consuming. So for breaking that, we were creating some armies and things. Well, still having some problems. So what I'm going to suggest here is, well, let's replace all the machine and clusters definitions with namespaces. So we are going to provision separate namespaces for each build out there. And we are going to run our tests on these specified namespaces. And if they are successful, we are going to tear them down. And then if not, we are going to keep them for a while. And this leads to ephemeral namespaces, and which is, well, as you can see, these are going to be some temporary namespaces. So whenever they're gone, all the system components will be gone. So as a definition, I can say that these namespaces are isolated environments that are running different versions of services on top of it. So as you saw in the previous picture, and also we are going to see another one, they are mostly identical but with different versions. Or according to your implementation, you can use them for testing different components of your infrastructure, and then in the end you can just combine them. And also these are the environments, these are the environments where we are running our integration tests and E2E tests, and then we are getting rid of them whenever we are done. So yes, what I mean by time-effective provisioning, at least spinning up an AWS instance at least takes 40 to 60 seconds or so, and then you're waiting for warming up services. You're waiting for your services to warm up. And yes, we are not in the age of sleeping in the data centers, but well, this was the best I can find about waiting in front of our computers. And also, what we mean by efficient resource utilization, yes, we are no longer running extra hosts out there. We are only running them if we want to scale up, or if our cluster is not enough for running enough containers out there. And also, as you know, well, containerization is much better about resource utilization. And now, we are just getting closer to how to use them, and we are going to get into details of this. So, happy path of a deployment process is you're going to run your unit test first, and then if it is successful, you're building your Docker images, and then we are deploying to Sandbox, but your approach will be different here. And after we deploy to Sandbox, we are running tests against this, and then if the test passes, and then we are deleting namespace. Eventually, we are updating the services to staging or production if they're all good to go. So, yep, not bad. I hope it's readable. So this is the first step. So, what we are going to do, or how does it look like to have identical namespaces out there? So yes, we have two separate deployments here. It includes all the same services out there, and then just the first one depicts version 1 of all the services. On the second one, we are updating Nginx and to-do service. And on the third one, we are this time updating just the Nginx. So yes, we have these three things running out there. And this is a look of how it seems. Actually, this has been kind of wrong. It would be better to list replication controllers instead of that, because it would be much more easier to see the versions. Now it's not giving much information, but only thing that you can see is they're all running two to-do services out there and one instance of Nginx. Just here, there's a one difference as Nightwatch, because, well, I just recently ran that at that point of time, and it was still going on. So how are we going to add E2E components? I'm not going to focus on running integration tests, because it's the process is much most of the same. Just with E2E, we are going to add some more layers on top of it. What we need here is a Selenium server. Yes, for now, we are putting Selenium server inside of the namespaces, and I know this is not efficient, and I'm going to talk about that somewhere near the end. And the other thing is Nightwatch.js scripts. Actually, how we are using Nightwatch is whenever developer updates the test scripts, we are building an image out of that, and at this point, we are making use of those images. Well, if life was good, we can assume that all tests passed out there, and then we're gonna delete our namespace. And, well, you're gonna see it's only taken 2 seconds or something at most. So they're all deleted. There were almost 12 or something containers. But you need to be careful about using this delete command on namespaces, because it's going to delete all your service definitions, replications, controllers, secrets, whatever you have. So, yes, this is the case where test gets failed. What are we going to do here is we are going to connect to our Selenium server for debugging purposes. So we are going to use a VNC server client. But how can we connect to this Selenium service? Because we said that it's isolated. So what is the ways for reaching the server? Yes, the first option is we can expose VNC port of 5900 out there. And on AWS, it's going to create an ELB instance. And then, yes, we will be exposing this port. And all their developers can access to this host. But the problem with this approach was, actually it was an issue of Kubernetes lately, and then it was creating the ELB and the related security group, and whenever we delete the namespace and the ELB instance, it wasn't deleting this security group, so we were hitting some thresholds out there. This was the main reason, but I got an notification email about that, about this problem is resolved, but still, this is not a good approach, because you're going to pay for those ELB instances, and then this is something that your developers is just going to access once or twice. So just for this, it's costly to expose these ports with that. The other option, I just lately heard about that, is kube control port forward. So if your developers has some kube config definitions there, you're able to forward your localhost request to here. We are forwarding them to Selenium, to this given port. If you are just going to define your local port, it's going to set a random port out there. And also we are giving the namespace name. And yes, after you did this, you can just run your VNC client and then connect to the Selenium server like you're accessing to your localhost. And also, this is kind of off the topic, but I need to mention about that. There are a bunch of Kubernetes features out there, and then it's really hard. It's something like finding needles in the haystack. They have them, and whenever we come across with them, we think that everyone else is doing knowing that except us. But I think it's not like that. At least what I feel like this. If you know port forwarding since the beginning, well, I would appreciate. But I wasn't. So now live in action part, but I have some concerns about how this thing is going to work, but at least show some of the stuff. Whoop. Yeah, this was our application out there, just listing some to-dos. So, oops. Yeah, you can just list them as done and then make some filterings, enter a new one. This is our thing. And how we are making the deployments is, yes, now we can just start talking about the Go CD part. Oops. And as I said, I'm originally a software engineer, so all the tools out there is new for me. So Jenkins was kind of new. We used that before, but I didn't do any configurations. And Go CD was something I just recently encountered with. So why I'm trying to use this thing? Because I really like how they're handling the fan-in resolutions out there. So suppose that you have or suppose that you updated both your front and back end code, and then normally it needs to be written with backward compatibility concerns, but your developers didn't do this. So you need to deploy them at the same time. So Go CD is capable of getting these two things within its fan-in approach, and then capable of deploying them all together. So when you check this thing, actually this is just a single level of thing, and it is showing that E2E test, to-do service, and Nginx as a dependency on delivery pipeline. And whenever any of these services triggers the build, then with their successful states, it is going to trigger delivery as well. And later on, you are also capable of, maybe if whenever your delivery pipeline is successfully completed, you can just add some new other pipelines there as well. Maybe you can run your security tests. If they all passes, then you can do some chaos monkey tests, and then you can just deploy this your stuff to production, and they're capable of handling this kind of stuff. So how they are doing this? Well, where was that? Yeah. They, for each dependency, they are setting some environment variables out there, so you're able to get the version and the service name. So just with some parsing operations, then you're able to get the latest version that you're testing against. Another thing that I would like to, before that I can just go back. So maybe you can ask about that, what are all these green bars out there? This means your stages, and then you're able to just separate your build process into these stages. So what this means is, for to-do service, the first green bar means build image part. The second part means deployment part. So whenever you encounter with a problem, even before checking the logs, you're easily able to see what's the problem. If the first bar is red, then it means that there was a problem with communication of Docker Hub or your Docker registry, whatever you're using. If there's a problem with the second part, then it means that there's a problem with the deployment. So when we go back to our slides, so if you're trying to provision your test environments, whenever it's triggered, we are just creating all the dependencies. So we are not checking any versions, we are not making any version checks or anything. But if you're trying to make a deployment, then it's comparing versions, and then depending on if it is something newly introduced, then it is creating the service. But if not, it's calling the rolling update. So now, I want to share some scripts. Honestly, I'm sharing all the codes out there, and then I'm going to share the links as well. But instead of getting lost within the code, I will just highlight what were the key points that I had problem with. Okay, the idea was running nightwatch scripts within a container, within a pod, and then whenever we are done with that, I was planning to get the exit code, and depending on that, I was just going to give the result. But the life wasn't good as it sounds. So, okay, I ran our nightwatch script, and then whenever I was done, it was just getting into this step, and it was saying that, well, it was exiting with code 1. For a while, I thought that I had a problem with my base script, and then I was just trying to change the status, and then trying to see if it's failed, if it's successful, or what. But then I realized, okay, it is done with that, but it is still in the running state for a while. So I just need to put a sleep state out there, and then wait for it to then completely. And for the Selenium part, I don't have much to share. I just put this manifest file out there. And also, within all the deployment processes, the most important part are health checkers. So whenever you think that something is deployed out there, you need to make a health check, because rolling update isn't giving any information about that. Whenever you use that, whenever it is somehow out there, it is saying successful, but then you're realizing that it's having some problems with pulling the image, or maybe it's having some problems with reading the secret file. So how we are going to do the health check? This is another thing that I recently learned. I always thought that it's not possible to access to your pods that are within your Kubernetes infrastructure, but then I learned this proxy endpoint. So by using this, you can just call proxy-namespace / your namespace name and service name, and then your endpoint for providing the health check. And also, I'm going to tell you where I got this code from, and I hope that will be another helpful point for you. So yes, this is, as you can see, this is a work in progress thing still. Yes, I'm trying to run, I'm just encountered with some problems and things. But there are some obvious problems around here, because you need to just keep control of namespace creation, because after a while, or at the end of the day, if you're not just keeping an eye on that, you're going to have a bunch of containers, or you're going to hit some limits. So actually this thing just come to my mind while I was on plane today. What we can do is, after we run our test scripts, if there's a problem, we can just scale down the pods and then say that, okay, we are not going to use this. We can write a script, and whenever your developers want to debug this, they can just scale up again, and then they can just forward the port and make their debugging. Another solution, but this doesn't look like a solution, you can delete some of your namespaces that are older than a certain age. Maybe they're 1 day older, so just get rid of them. But I don't like this solution. And also, as I told you, currently I was running Selenium instances within the namespaces. I don't have much experience with Selenium, so I need to read a bit more about that. But and also, I didn't, while doing the first implementation, I didn't know of port forwarding and things, and I thought that everything needs to reside on within the namespace, but it's not. So I will try to think about a better solution, because every Selenium instance is consuming 500 megabytes of RAM, and then when you run 10 namespace, ephemeral namespace out there, it's going to consume 5 gigs, and which is too much. So this doesn't look really related with the presentation, but this is something I've encountered with while trying to build the actual code. The problem is, okay, you're isolating your environments, you're creating your secrets, you're just defining some access policies and then preventing your users, your developers to access some of the stuff out there. But if you're somehow exposing 8080 port, then all your work is done because everyone else will be able to access to your secrets or whatever they want, and also they will be capable of doing everything. So what I mean by exposing 8080 port, well, it's not something like, okay, you can access it internally and then just you can block this for the users outside of the network. No, I would suggest you to just open it up for your localhost of the master, and then just leave the rest, because you're not gonna need it. And if okay, so another thing for running this stuff, I ran Go CD server and agents within pods. So actually, I'm not doing that in our actual environment, but I tried to do that, and then I tried to set some SSH keys out there, but it didn't work as I expected. When you check documentation, you're going to see that you can define ID underscore RSA within your secrets, and then you can make use of them. But the problem is, or the first problem is, Kubernetes manifest files doesn't support underscore within the field names. Okay, it's not a biggie. I can just change it to ID-RSA, and then I can just define a config file out there, and I can set as, okay, for GitHub, use this SSH key. But this just leads to another problem. This time, Kubernetes secrets are created with read-only permission, so it will be read-only for all the users and groups. So as you can guess, SSH is complaining about that. It is finding that it's too exposed, and it's not allowing that. So both these issues, or not the first one, but the second issue is going to be handled in a while. They're going to set some privileges for defining the secrets, but well, the issue is open there. Another thing, make use of some kubelet arguments, like, because we are going to create a bunch of namespaces and we are going to kill a lot of containers out there, so they're leaving it's leaving some dead containers out there, so you need to set these as whatever you want. So these two links will be important for KubeCon. After this conference, I'm going to write a documentation as well. You can check some codes. I'm going to edit up on that. I'm going to experiment on that. And also, I'm not really sure if you've heard of this contrib repo out there. I told you I'm going to share where I got my health checker code. It's just like from this contrib repo. They have a bunch of useful scripts out there, and I would suggest you to take a look at that. So thanks to Part, I really appreciate what Kubernetes team is doing, because whenever I think about a feature, I'm realizing that they already implemented it. At least, even it's in early stages, they did. Yeah, thanks to my current company for sponsoring me here, and then just providing me the environment to work whatever I want. Quests, who helped me about the front-end part, and then integration tests, E2E tests, sorry. And a UK consulate in New York. Well, I hardly get my visa, and then I just canceled my flight, and just this morning I arrived here, but at least here I am. So that's it. Just I'm going to get the questions. We have just 5 minutes left.
5 minutes for questions, anyone? Yep, one there.
Hi. So the GoCD Kubernetes integration is currently based on the bash scripts
Yes,
calling
rolling updates and things.
kubectl. Okay. Do you plan on changing that? For example, using deployment manager or something more sophisticated?
Yes, I'm planning on that, because the problem is I'm always saying that I'm a software engineer, and for about a month I have been tackling with bash scripts. So I'm kind of new here, and I always prefer tools and built-in applications out there.
Any more questions at all? Check over here. Oh, one funnel.
Oh, cool.
So how do you include new versions of Kubernetes in your end-to-end tests?
New versions of...
So when you update from 1.1 to 1.2, how do you apply that?
Well, we are using Hypercube. So mostly Kubelet is handling the... whenever you need to update one of your pods or containers, Kubelet is handling that part. And since we are using Hypercube, Hypercube is an... all our system components are running as pods again. All our API scheduler, API server, scheduler, controller, manager, all are running as pods.
But you previously had a case where you would recreate the cluster each time, correct?
Oh, but I'm not creating cluster each time. I'm just creating the namespaces each time.
Right. So, but if you aren't recreating the cluster each time, how do you know if the new version of Kubernetes has broken your system or not?
Good question. Well, very good one. I have no answer for this, but I need to just think about that. But thank you for that, because I'm pretty sure that this system has flaws, but I don't have anyone else to just discuss about that.
This is the
So
beauty of
thank you for
conferences,
that.
Can, yeah? People come, give you good ideas.
Yeah.
What it's all about. Any more questions at all? I think that's it. So one more time, let's join me in thanking Can.
Well,